This is yet another situation or design, quite unrealistic and very bad OSPF design, in which we need to somehow make this work. So area 2 should be directly connected to backbone area 0, but it's not. And on top of that, the area 3 is not connected to area 0, it's connected to area 2, which in turn has already a problem connecting to area 0 and exchanging routing information. So obviously the proper design would be to make sure that area 2 is directly connected and area 3 is directly connected to the backbone area. But for the time being, as a workaround or a temporary solution, we can use a virtual link. But how would we use that if we have this kind of situation? In the previous situation, there was only one disconnection. Obviously, I simplified the topology here, so it's better to look at this. But OSPF is already running, and of course nothing is going to work because the exchange of information between area 3 and area 0 does not exist. If in fact I jump to this internet 1 router here, let's see what we have here. So show IP OSPF neighbor. I have a neighbor, so my neighbor is 1111, but if I look at the routing table, it's empty. There's nothing. We're not learning anything because area 2 is disconnected from area 0, so area 3 cannot possibly learn that either. So how do we make this work before we redesign and create a proper design where all the areas are directly connected to area 0, the backbone area? The first thing we need to do, we need to patch, we need to make sure that area 2 is receiving all those prefixes because they are not receiving those. So we need to create a virtual link between R4 and R5. So current problem is that R3 is not directly connected to ABR. So to do that, we need to extend the area 0 using this virtual link between R4 and R5 so that the R1 thinks that it is connected to ABR. So extension of area 0 is the virtual link between R4 and R5. When I do that, it's going to work up to this point. So let's go to R4 first and create virtual link. So to create a virtual link and extend the area 0, we need to consider that area 1 is a transit area where the virtual link should be configured. The virtual link, like in previous lab, is simple configuration in OSPF. So OSPF is already running. My area 1 is a transit area which will have virtual link connection from R4 to the router 5, and we need to do the same thing on R5. So we need to go to configure router OSPF 1, and the area 1 is a transit area containing virtual link to 4444. So when this is done, show IP OSPF virtual link. The link shows us up connection to 4, and at the moment, what's the state here? Show IP OSPF neighbor. We have this virtual link configured. So now at this point, R1 should be learning the networks from area 0. Let's see that R1. Do we see anything? Show IP route OSPF. And just to see that, let's say R6 loop back here is learning. So we are now good up to this point. But my internet 1 router here at the moment, if I repeat my OSPF command, it's not learning anything. So again, we have the situation where R1 thinks it is connected to area 0 because this extension here of area 0 over area 1 on R4, it's an endpoint of virtual link. But internet 1 does not know area 0 yet, so we need to further extend that area 0 over another transit area, which is area 2. So I need to create another virtual link between R1 and R4 for this to happen so that internet 1 thinks it is connected to area 0. How do we do that? We're gonna go to R4 back again, and we will say area, this time transit area is area 2, where the virtual link is going to be configured. Area 2 virtual link connection to 1.1.1.1. So now we have 2 virtual links here. And we're going to jump to R1 and say conft router OSPF1 area 2 is our transit area. Virtual link is going to be connection to 4444. Now, if that happens, show IP OSPF virtual link. State is up. The process came from loading to full. Loading is done. Show IP OSPF neighbor. We have a neighbor over virtual link here, so we have actually now on our 2 of those. Show IP OSPF neighbor. 2 virtual links, one towards towards R1 and one towards R5. And now at this point, since we extended now, we have 2 virtual links, the area 0 spills over area 1, area 2, and now Internet 1 thinks that it has connection to area 0. Let's verify that. It should be learning all those prefixes in OSPF, and it is learning all those. So we see, for example, 6666, which is advertised by router 6 here. And that's how it's done. Obviously, that is not a proper design. It's just a temporary solution for this to work. And this network should be redesigned such that every area is actually directly connected to area 0, not via virtual links.